So when we covered multiplication, addition, and subtraction of polynomials, I mentioned that we weren't doing division then, because division with polynomials is a whole other thing. This video, we're going to cover dividing polynomials. There's two basic ways we divide polynomials: long division when we have to, although we prefer synthetic division. The thing is, synthetic division is easier, but you can't always use it, and I'll unpack that as I go through my examples. Once we've covered both types of division, I'll show you about using division. Specifically, we'll use synthetic division to factor a polynomial. Really, you use synthetic division to start factoring a polynomial. Then you're going to follow up with other types of factoring that we've covered in previous lessons. So when we look through here, I'm just going to go through. I have 4 examples, and that'll pretty much cover us. When you're dividing two polynomials, unless you know how to do synthetic division and when to do synthetic division, you're pretty much stuck with long division. This works much the same way as it does with big numbers. You've learned long division in elementary school. So I'm going to make a long division symbol. I'm going to put the dividend in the inside. X cubed plus 3x squared. Normally you could just put minus 7 here. Typically speaking, though, you want to watch out for missing terms in polynomials. In this case, the x term is missing, so I'm going to put 0x in that spot. It's not really necessary, but it's a good habit. It makes things simpler a little later to keep everything nice and tidy. On the outside, then, the divisor, x squared minus x minus 2. The thing that makes polynomial division different from with numbers is that because we don't know the value of x, there's no interaction between columns. So I can't, with long division with numbers, I worry about all the numbers on the outside and all the numbers on the inside. With polynomial long division, there's no interaction. So to find the first term in my quotient, I concern myself entirely with the leading coefficient of the divisor and the leading coefficient of the dividend. So what I need to do is take x cubed and divide it by x squared. Or usually I find it a little easier to think it backwards. What do I need to multiply by x squared to get x cubed? And the answer is x. X squared times x is x cubed. Now once you have the first piece for your quotient, you need to multiply, and for that you will need to distribute by the entire divisor. So x times x squared is x cubed on purpose to make these match. But then I keep going. X times negative x is negative x squared, and x times negative 2 is negative 2x. At this point, this is my factor here. I need to subtract that out to find the remainder so that I can keep going. So I need to subtract. The easiest way to subtract polynomials is to change all the signs in the second one. So I go through, I change all the positives to negatives and all the negatives to positives. And then I'm going to add. So you change all the signs and then add. It's how you subtract polynomials. So x cubed minus x cubed is nothing. That's on purpose. If that doesn't work out, you've messed up. 3x squared plus x squared is 4x squared. Nothing, and 2x is 2x minus 7. So this is my remainder. Now I repeat the process. So what do I multiply by x squared to get 4x squared? Is 4. Then when I distribute, I'll get 4x squared minus 4x minus 8. In order to subtract, I go through and change all the signs and then add. Nothing, which is good, 6x and positive 1. Frequently, you'll do several more iterations, but you'll know it's time to stop when the degree of your divisor here, when this x squared, is bigger than the degree of your remainder. You can't really divide anymore. So what you have left here is a remainder. The remainder is 6x plus 1. Depending on how you've been told to give your answer, you may actually give these as two separate things. This is the quotient and this is the remainder. Or you can put the remainder into a fraction with the divisor underneath it. X squared minus x minus 2. So this is the correct answer for this division problem. X plus 4 is the quotient, but it doesn't divide evenly. There's a remainder, 6x plus 1. That's long division. which, like I said, is mostly the same as with numbers. I mentioned a couple of differences. If what you're dividing by is a linear factor with a leading coefficient of 1, that is, it can be written as x plus a number or x minus a number, then you can use something we call synthetic substitution. You've seen this if you've been watching my videos. You saw this in 5.2 when we did we called it synthetic substitution at the time. I said it would come back, and this is it. So basically the way this works is first you have to interpret your divisor into the form x minus k. Now the fact that this says plus means that we have the wrong sign. This is actually x minus -3, which is how it came to be seen as x plus 3. So k in this case is -3. And so that's what goes in my little box over here. And I'm assuming well, I won't assume you remember. So you copy down just the coefficients from the dividend here. 3, 17, 21, -11. Bring down the first number, then you multiply by what's in the box. -9. 3 times -3 is -9. Then you add. That's 8. Multiply by what's in the box. -24. Add. -3. -3 times -3 is +9, which leaves a remainder of -2. The last number in synthetic division is the remainder. And that's going to be very important for us most of the time. In this case, we just learned this doesn't divide evenly. There is a remainder. The remainder is linear because we were dividing by something that's just x to the first. So if we had done long division, we'd keep going until there's no x's left in our remainder. When we did this with the synthetic substitution, what we said was the remainder is the same thing you get if you stick -3 into this polynomial on top, which is still true. If you stick -3 in here for all these x's and work it out, you'll get -2. More to the point, these other 3 numbers are the coefficients for the quotient. You can build this from left to right. If you note, it started as cubic. We divided by a first degree polynomial, which means our quotient should be second degree. This is 3x squared. This is 8x, and this is -3, just the constant. Or you can build it from right to left. Remember, the first one's the remainder. Then you've got the constant, then the x squared term. No matter how big it is, if you go right to left, just start with nothing and work your way up. If you start on the left, just remember to subtract 1 from the power. So 3x squared and 8x minus 3 with a remainder of -2 over x plus 3. So there's our division problem solved with synthetic division. You can only do synthetic division if the bottom is of the form y minus k. Let's do another one of those just to show you how this works again. So here I've got a 2x cubed plus 9x squared plus 14x plus 5 divided by x minus 3. So in this case, since it's x minus k, k is actually +3. So I'll put that in the little box here. My coefficients are 2, 9, 14, and 5. Don't forget to look for missing terms, which there aren't any of, but if there are any, you have to put in that 0. For synthetic division, it's very important you put in the 0. So bring down the 2. 2 times 3 is 6. When I add there, I get 15. 15 times 3 is 45. Oh, this is going to be really big. 14 and 45 is 59. 59 times 3 is 147. When I add 5, I'll get 152. So that's my remainder. This is 2x squared and 15x plus 59 with a remainder of 152 over x minus 3. So there's synthetic division again. Just add, multiply all the way through. Most of the time, when we're using synthetic division in an actual applied problem, we are trying to solve a polynomial or factor a polynomial in order to solve it, usually. So in this example, we have our polynomial 2x cubed minus 11x squared plus 3x plus 36, and we've been given the information that x minus 3 is a factor of this polynomial, which tells us a couple of things. If I stick 3 in for synthetic division, I should get a 0 as my remainder, because x minus 3 is a factor of this polynomial. So there will be no, the remainder will be 0. There'll be no remainder. And that means my synthetic division will work out neatly by the time it's done. And I can start to factor my polynomial. So 2x cubed, negative 11x squared, 3x, and 36. Bring down the 2, that's 6. Add to negative 5. Multiply is negative 15. Add to negative 12. Multiply to negative 36. Add to 0. So there's my 0 remainder. This is 2x squared minus 5x minus 12. And the front is x minus 3. That's what I divided by. So one of the factors is x minus 3. The other factor is this quadratic, which I should be able to further factor. So 2x times x makes 2x squared. I need the middle to add to negative 5x. So if I do, say, 3 and 4, oh, that works. If I put 3 here and 4 here, those will multiply to 12. And if I add, this will be negative 8 and positive 3, which makes negative 5. First guess. Oh, so this is completely factored. And now we factored. If this were an equation equal to 0, I could now figure out what makes each of these factors 0 in order to solve the equation. So this is how we use synthetic division to start breaking down polynomials of large degree. We did earlier when we did factoring, we looked for patterns, and like that's still a valid way to approach the problem. Doesn't always work out. When it doesn't, synthetic division will help us to break these down. That should be enough to get you started in this section. If you need any help, as always, please feel free to ask.